points are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 disjoint sets of objects, which means subsets of connected grid points. They have 4 connected components. First component 0, second component 1, 2, 3, 7, third component 5, 6, fourth component 4, 9, 8. Find query. 2 and 7 objects are in the same set. To find that, 2 objects must in the same component. So yes, 2 and 7 in same set. Union command. Merge is merge sets containing 3 and 8. To find that, add the connection between 2 grid points. After the connection, there have 3 components, which are first component 0, second component 1, 2, 3, 4, 7, 8, 9, third component 5, 6.
Find operation. The two objects P and Q are connected if and only if their entries in the array are the same. For example, let's consider an array named ID of size 10 with the values 0, 1, 1, 8, 8, 0, 0, 1, 8, 8. As we can see, index 0, index 5 and index 6 has the same ID as 0, so they are connected. Also, index 1, index 2 and index 7 has the same ID as 1, so they are connected. Finally, index 3, index 4, index 8 and index 9 also has the same ID as 8, so they are connected.
Now let's see the union operation. In the example, here we are checking ID 6 and ID 1. The P is equal to 6 and Q is equal to 1. Therefore, 6th position we have the ID 0. For the first position we have ID 1. Those IDs are not matching. 0 is not equal to 1. So 6 and 1 are not connected. To merge components containing P and Q, change all entries whose ID equals ID P to ID Q. In the example, P is 6 and Q is 1. In order to connect, we should change all entries whose ID equals to ID P. So P is ID 6. ID 6 equals 0. That 0 should be changed with the ID of 1. So 0 will replace by 1. So you can see here we have to replace 3 components. The problem is many values can change.
Now we will look into the quick find implementation in Java. We need 2 attributes, an integer array which is declared as myId and an integer variable for count that keeps count of the connected components. Then we write a constructor that passes the length of the array as a parameter. So when we are creating a quick find object, we can define the array length. Count equals n because in the object creating time there are no connected components. Then we initialize the myId array as a new array with the length of n. Finally, we assign values to myId array using a for loop. Beginning from the index 0, we assign the I value to each array index in each iteration. So if the array length is 8, array element values will be from 0 to 7. Then we have the connected method, which returns true or false. This method checks if P and Q indexes are connected or not. If they are connected, then they will have the same value and will return true. If they are not connected, it will return false.
In this count method, we are returning the correct number of components. Union method, we are using this union method to connect two components. We have to pass the components that we need to connect as arguments to this union method. We first assign the ID of the first argument to a variable and the second one, and then we have to check whether these IDs are already equal. If these IDs are already equal, we have to return from this method. If not, we have to iterate through the whole array and check for the entries whose IDs are equals to the first argument's ID and set those values to the second argument's ID. And as these two components are now equal, we had to reduce the count by 1.
Here's the code for the quick find algorithm. So first you need to create a class. My class name is QuickFind, and then you have to initialize the variables. The variables depicted here are an array of integers which is in the name of my ID, and then int count. After that you have to create a constructor and pass an integer parameter, and then you have to equal it to the count variable and set it as the size of the array which we initialized above. And then here's a for loop which is iterating n times and creating elements to the array. After that we should write a method to see whether the two indexes are connected. For that we should write a method called connected and pass two parameters, which is in my case in P and Q. And then the method simply checks whether the ID of P is equal to ID of Q, and it will return a boolean value which is true or false. And then again we have a method to count the current number of components, and it will simply return the count. Here's the union method which is used to connect two indexes. For that you have to pass two parameters. In my case the parameters are P and Q. And then you have to create two instance variables, PID and QID, and then set PID equal to the index of P in my ID array. Do the same to Q also. And then if P and Q are already in the same component, this if loop will return false. Again here's a for loop which is iterating of the size of my ID array, and it checks my ID index is equal to PID or my ID index is equal to QID, and then it will reduce the count by 0 if one of that are correct.
Here we are going to talk about time complexity. We should know how to define an algorithm, and we have to see the usefulness of it. It is defined by two parameters. The first one is time complexity and the second one is space complexity. Time complexity of algorithm